All right, in this video, we're gonna have a nice little introduction to some probability concepts. Okay, so in the last unit, some videos back, we discussed frequency tables. You remember frequency tables where you had your different data values or classes, and we had the associated frequencies. Okay, so what we could do is we could really treat frequency tables, we could use those to calculate what's called a probability distribution. And so what's a probability distribution is that basically it's just a listing and it's telling you what's the likelihood or what's the probability that each event will occur. Okay? So before we jump into actually calculating your probability distribution, I wanted to go over some properties that we'll be using throughout the rest of the semester. First property is that each probability has to be between 0 and 1. That's very important. So a probability has to be either between 0% or 100%. Okay? As far as decimals, that's what we're saying. That's what the 0 to 1 represents, decimals. Okay? As far as fractions, it has to be a proper fraction. Your probability cannot be less than 0 and it cannot exceed 1. To be a true probability distribution, if we add up all the probabilities of all the possible events, that sum has to equal 100% or 1. So that's what that second property is telling you. If you add up all your events, you have to equal 1. Now, of course, we may have some issues where we have a little bit of rounding issues, and we may be slightly less than 1, but or slightly more than 1, but we should be really, really close to 1. Just a couple quick examples here. So first one here is we have a frequency table. So consider the following frequency table that is the result of asking students, hey, what's your favorite color? Okay? And so what we need to do here is we need to use this information to figure out a probability distribution. Okay? So what I mean by that is I'm going to see if I could draw another column here. And I'm going to call this is an indication we're going to be using the probability of X. What I mean by that is what's the probability that we select a student that likes red? What's the probability we select a student that likes blue? So on and so forth. That's what that P of X notation represents. Okay? All right. So to figure out these probabilities, once you have a frequency table, it's actually really straightforward. And in fact, we've done it before. These probabilities are nothing more than relative frequencies. So if you recall, to figure out a relative frequency, we first of all need the total frequencies. So I'm going to come down here, I'm going to add up all my frequencies. So if I take 5 plus 10, that's 15, plus another 5, that's 20, 25. So I'm getting, and y'all please double check me, I'm getting a total number of frequencies of 25. Okay? So then what that means is that the probability that we select a student that likes red as our favorite color is going to be 5 out of 25. That is the probability of us selecting a person that likes red. A person that likes blue, 10 out of 25. So as you can see, all of these are just simply relative frequencies. You take the number of people that like that color divided by the total number of colors. So what's the probability distribution? I'm going to highlight it for you. This is the probability distribution. We have red, blue, green, black, and the other colors, and then we have the associated probabilities. So a probability distribution consists of the data values and the events, I guess we could say, and then the related probabilities of those events. Okay. All right. Once we have a probability distribution, something that has a really cool context in a lot of different fields is the concept of expected value. So an expected value is the weighted average of all possible outcomes. Think of an expected value as being the average of a game that you play an infinite number of times. The expected value is the mean of the probability distribution. Very important. So anytime you're asked to find the mean of the probability distribution, you're finding the expected value. They are synonymous. An expected value, the formula is, it's the summation. So we're going to be adding up some things. We're going to be adding up. What you do is you take your data value all right? And then you multiply it by the probability that that value will occur. Okay, you're going to add up all of those those products, those pairs of products. Okay, let's do an example here. Suppose you place a $20 bet on 00 on a standard American roulette wheel with 38 numbers. If 00 is spun, your payout is a net gain of $600. What is the expected profit of one spin of the wheel with this bet? What is your expected profit if instead you play this game 10 times? Okay. All right, so let's talk about this. So the first step in figuring out this expected profit, this expected value, is that we need to construct the probability distribution. Okay. So how do we do that? So this is what we're going to do. We're going to let X represent the net gain. Okay, X represents the net gain. How much we're going to walk home with if we play this game, all right? So, first step is we need the probability distribution, okay? The left side of this, I'm going to let it represent X, the net gain, and the right side is going to represent P of X. What's the probability that we walk home with that particular amount of money? Okay? So let's talk about X. What are the possible values of X? AKA, what are the possible net payouts we can have? What's the possible amounts that we can walk home with? It says, suppose you place a $20 bet on 00 with 38 numbers. If you land on that 00, you win, and your net gain is $600. So that is one of our possible net gains, $600. If we win the game, we have a net payout of $600. And because it's net, it's already compensating for the fact that we paid the $20 to play the game. But then what happens if we lose? If we lose, we don't win anything, but we paid $20 to play the game. In that case, our net payout is going to be a negative $20. So very important, y'all, especially when you're doing your homework questions. There are going to be a few of these questions. Make sure you always account for the case where you don't win anything. Especially in casinos, that's the most likely case anyways. All right, so $600 or negative $20, those are our two payouts. Now the question becomes, what's the probability that we win the $600, that we walk away with $600? Well, there's 38 numbers on a roulette wheel, okay? Only one of those numbers is the 00. So only one of the 38 numbers on a roulette wheel is 00. Therefore, the probability of getting $600 is 1 out of 38. There's only one 00 on a roulette wheel. Okay? So then, if the probability that we win is 1 out of 38, then the negative 20 represents the case where we lose. Well, if there's one number out of 38 that's going to win the game for us, that means that there's 38 minus 1, aka 37 numbers that will lose for us. So then 37 out of 38 is the probability that we have a net gain, or in this case a net loss, of $20. Okay? All right, very important. So now once we have the actual probability distribution constructed, now we can go in and calculate the expected value. Okay, we'll do this in a different color. So the expected value, which is the same thing as the mean, and this is what you do. The formula says you take, I'll write the formula down for you. It's the summation of your data value times the probability that you get that value. So for us, what does that mean? That means our first value of X is $600. So we're going to take 600 and we're going to multiply that by the probability that we win $600, which is 1 out of 38. Plus, because that's what that sigma notation means, plus now we take the next X value, which is a negative $20, and we multiply it by the probability that we lose $20, which is 37 out of 38. So I'm hoping you guys are seeing the pattern here. What you do is you multiply these things together. You take X times P of X, right? You take 600 times 1 over 38 plus what you get when you multiply a negative 20 times 37 over 38. Okay? So now let's go to our calculator. Let's see if I have that loaded up. Yeah. All right. So we're going to do, let's see, 600 times, in parentheses means times, 37 divided by 30. Nope. No. So the probability we win $600 is 1 out of 38. My bad. Plus, now open parentheses, a negative 20. So make sure you hit your negative at the bottom here. Negative 20. And then that gets multiplied by its probability, which was 37 divided by 38. Let's calculate. Into 2 decimal places, we get a negative 3.68. So mu equals a negative $3.68. So what does that number mean? That number means that if we play this game a bunch of times, sometimes we're going to hit 600. A lot of the times we're going to lose $20. If we were to average up all of those winnings and losses, we're going to end up having an average net loss, it turns out, of $3.68. So what does that mean? Should we be playing this game? Probably not. But the key here is that this is the cost, or excuse me, this is the expected value for one play of the game. Let's go back to the other question. The other question, remember, says, what is the expected profit if we play this game 10 times? Well, for 10 times, let's move this up. 10 times, all we do is we take the amount, it would be for one spin, which is a negative $3.68, multiply that by 10. I don't need a calculator for that. That just means move the decimal place to the right one place. We're going to get a negative $36.80 is what happens if we play this game 10 times. So now it's even more clear. We certainly should not be playing this game. All right, so I hope that clears up some of these concepts of probability. I will see you guys in the next video.